Okay, so I'm just doing another video on simple harmonic motion, and I'm just going to do some harder worked examples, and I've already done the solution, so we'll just work our way through them. Okay, so in this particular example, a particle moves with simple harmonic motion, so that its displacement x on a fixed point is given by the formula. Okay, so find an expression for the velocity, the acceleration, and prove that the motion is simple harmonic motion. So this thing about proving will come up a few times. Okay, so the first thing is we write down x, okay, and then x dot is the velocity, so I just derive 4 sine 2t to make it 8 cos 2t, and then acceleration is just the derivative of the velocity, and so cos turns into minus sine, 2 8 is 16, and then I've got to prove that it's simple harmonic motion, so I've got to prove that it's the acceleration is proportional to the distance displacement. So I've got to break 16 sine 2t up into 4 sine 2t times minus 4, and then that expression is that expression there. Okay, so then I've got minus 4 times x, so I have the acceleration is proportional to the displacement, so that means I've got simple harmonic motion. That's pretty straightforward. This angular velocity is the coefficient, so omega squared equals 4. So omega equals 2, so then once I've got that, I know that the period is going to be 2 pi over 2. So I know that the period is going to be pi seconds. Okay, the amplitude is actually going to be 4, and the period is going to be pi. Okay, so copy that and come across. Okay, so I've got another worked example. Acceleration is minus 16x. State the period. If x equals 0, v equals 4, when t equals 2, find x and find the amplitude. So first of all, we've got the acceleration exactly in the form of proportional to the displacement, so it's simple harmonic motion. Omega squared equals 16, so omega equals 4, and the unit is radians per second. So the first thing we need to do is find the period. So the period is 2 pi over omega, which is just pi on 2, so that's the period. Okay, now to find the rest of it, we've got to do a little bit of equation solving, I think. So we've got displacement from first video equals a sine omega t, and velocity equals 4a times cos omega t. Now we know that w equals 4, omega equals 4, so I've got 4a, and then in information I've got the velocity is 4 when the time equals 0, so I just sub that in, so I get cos 0, which is 1, so 4a equals 4, so a equals 1, so that's the amplitude, and so I found the amplitude, I found the period, and I have to find x at any time, so I just go back, actually, so that's the velocity, and so finding displacement, so x will equal a, 1 sine 2t, okay, which is just sine 2t. Hang on, omega equals 4, I beg your pardon, sine 4t. Okay, and obviously, I just got to check that. Hang on, have I done something wrong? Oh, velocity equals 4a. So the velocity is 4a, so that should be a 4 there. Sorry. Okay, and x equals sine 4t. Okay, copy that and come across. Okay, so we've got another question with a fully worked solution. So again, I've got the acceleration proportional to the distance, so I've got simple harmonic motion, but I've got to find the period, the amplitude, and displacement, and you get some clues here. Okay, so obviously omega squared equals 4, omega equals 2 radians per second, so the period equals pi, so I've done the period. Now the rest of it is a little bit harder. Okay, so I've got the formula for displacement, and then I put in the numbers I do know. So I know x is 3 when time equals 0, so I end up with this first formula in green. So I get a cos c equals 3, but I can't do anything more because I don't know what a is and I don't know what c is. So the velocity formula is minus omega a sine omega t plus the constant, and so I put in that number when t equals 0, and you end up with that formula there. So I've got a formula in green and a formula in orange, and then if you divide those two together, you get a tan relationship, and so you end up with the a's crossing out, So sine over cos is tan, the 3's cross off, so c equals pi on 3. Yeah. And so I end up with, chuck this number back into here. So I've got a cos c pi on 3 equals 3. Cos of pi on 3 is a half, half equals, so a times a half equals 3, and then double both sides, you get a equals 6, and so x is 6 cos 2t plus pi on 3. So it's going to be, amplitude is there, the period comes from there, and this just means it's not being centered. It's not starting at 0. Okay, so copy that and come across. We've got one more to go. Okay, so this is one of the ones where you have to prove simple harmonic motion. So the velocity is that, and we have to show that the motion is simple harmonic motion, and then find the center, because it's not going to be on center, the period, and the amplitude. So first of all, it's given as v squared, but if I do half of v squared and half both numbers, I can get the derivative of a half v squared, because from previous work, the derivative of a half v squared is the same as the acceleration. So I get the derivative of that, so I get the derivative of that side, and that just turns into 2 minus 2x. So I take out minus 2 as a factor so that I can get x as the first number. So I get x minus 1. So then this is in the form of simple harmonic motion. The number there is equal to omega squared, so omega equals root 2 radians per second. The center of motion is the opposite number here, so the center of motion is 1, and we'll follow it up in a second. The period, okay, so the center of motion is 1. That's just the opposite number of the bracket. The period is 2 pi over omega. Root 2 into 2 goes root 2 times, so the answer is root 2 seconds. Now to get this last thing, the amplitude, we know that at maximum amplitude, the velocity equals 0. So when the particle is at its maximum, the velocity equals 0. So we end up solving that equation. So we take if v, we can just take that expression, even though it's v squared, we can just say that is the v formula, because basically if v equals 0, then v squared equals 0. Okay, so I can just take that. So then I just factorize that, and I get x equals 3 and minus 1. And so what's happening is the particle is starting at 1, it's going as far as 3, and then the velocity equals 0, and it's going back to minus 1, and the velocity equals 0. And so the amplitude is 2, because it's going 2 in both directions. Okay, so hopefully that gives you some more examples for you to help you with your work. Okay, bye.